Hello, my name is Matthew Suarez, and I'll be going over my senior project, which is about predictive data analytics. So for this project, I worked with Campus Dining to create a forecasting system capable of making accurate daily menu item forecasts of their PCOS menu items. The reason why I decided to do this was because their problem came from inefficient daily stocking of food items, which incurs costs when supply is not met with demand. Here's the problem statement written out officially. So for this project, you can think of it in four distinct parts: the forecast algorithm itself, the UI to display this forecast, the economic justification, and the accuracy tests comparing it to live data. So starting off with the algorithm itself, here's a brief glimpse into the data. This specifically is the burrito bowls sold over the course of January. Now, I have more data than this, but I just wanted to show off a single month to show off what each week looked like. So here we can see each week has a huge rise and fall, as we would expect. And using that, we can derive a decomposition of the data. This goes back over, I believe, April, and the reason being is because I discovered that going too far back wasn't exactly very helpful for the ARIMA model, as I'll discuss on the next slide. But as we can see from this decomposition, this right here is the seasonal, or what's being repeated generally over each week. And then this is the underlying trend line behind it. And then this is the remainder. And basically using that, we can develop the ARIMA model, which stands for Autoregressive Integrated Moving Average. And we use this to make generally accurate predictions, keeping in mind both the seasonality components and the underlying trend line from that decomposition. This goes back to the end of spring break, and the reason being is because the spring break having zero sales interfered a bit with the time series, so I decided to just exclude it, as most of the data before that ended up not being terribly relevant to the ARIMA model anyways, as we have plenty of data points to work with just from April and March and the beginning of May. So ARIMA model wasn't the only model I did. I also did the naive model, which is the simplest of just using whatever's last day value was for your forecast. And I also used a seasonal naive, which is basically treating each day as if it's its own season. So, for example, if you wanted to predict what you're going to sell on Monday, the seasonal naive model would say simply to use last Monday's value. And it seems to be, from these various accuracy measures, that the seasonal naive is actually beating the ARIMA model by just a little bit. Generally, the standard one to use in industry is the mean absolute percent error. So as we can see, the seasonal naive is just a bit lower than the ARIMA, but these are both considered very good scores. But because the seasonal naive is better, it's going to be the one that I'm going to be selecting. Something I've learned from this project is sometimes the simple methods kind of beat out the more complex methods, or complexity isn't always good. So using that, I can create this UI, and basically this is just a screenshot, but they can select their item that they want to forecast, and then it'll display their ingredients, and as well they can select a date, and it'll go out as far as they select. Classes used, mainly IME 410, but also a lot of the programming aspects from 312 as well. So for the justification, I do not have their actual forecasts to compare because they don't have any, but he's going to send me more data, so I should be able to measure this better. But for now, the primary advantage is just saving more money from throwing out less food, and the secondary is less food. And then the cost, there's a minor cost for this